Yes? Yes? So you need, of course, the C++ desktop development, and what you will also need is, for good measures, the Visual Studio 2019 toolchain. So if we go here on the installer, after it was already executed, you still see what packages were selected. So this is my selection. This is like the most important additional thing you need to add. The rest, which you see here, is rather optional. You probably might not need that. But it's good to have, since it allows you to create also programs for other architectures. Any other questions? Okay, so while we are waiting for more people to come, let me quickly tell you what we will learn during the lectures in this part of the semester, so in the part 2. We will mostly take a look into using C++ to so we assume that we already can use C++, at least the basics, and we will learn how to use the Qt framework to practically create nice applications which might later be used in our scientific applications. So we'll take first a look on Qt and how it works in general, and then we will take a look on some useful libraries that help you to create UIs which are relevant for scientific and technical applications. So especially the QWT library, which allows you to create really nice plots and graphs, as well as provides control elements like knobs and switches which one might want to have in a UI, which later would be used by people in the lab, for example. Since a couple of versions, Qt as such provides also a set of own plotting built-in libraries, but since they are not LGPL licensed and not part of the most liberal Qt version, we will not be using those, especially given that there is this nice alternative library. So everything we will be using in our work and during this course are things which are licensed such that they can be used in closed source applications if one wants later to write such a thing. Yeah, so I see some more people came. So as I mentioned already before, we will be waiting till 15:15 with the actual start, so that even more people can come. We are still missing 6 people who were initially registered. Another thing to say is that the screen view that you see here will be recorded, and I will share that on YouTube. You will also hear my voice, but if I set up everything correctly, you will not hear what other people might say. So if you later have questions, first of all, I should repeat the question. Secondly, if I forget that, you will only see my answer, but not hear who asked what. I hope that will work out properly. I guess that's the best option from a data protection point of view. The recording is not really much edited, so it will not be much better than the lecture, hence just watch the lecture in original, then you at least can ask questions. Since this is a Vorlesung und Übung view sort of thingy, first of all, there will be some homework that you will be scheduled to do, and secondly, you might also have opportunity to do something live during the lecture. Depending on how many people we will have in the end, that opportunity might be bigger or smaller. If you are wondering which parts of Qt to install, we can also quickly start again the Qt installer and see which components have been installed for this virtual machine. Once it's loaded all the data, we don't want to send anonymous information. Here we don't change anything, we just keep it where okay. We need to use some other directory such that it allows us to install again at least select the component. So for the installation here, we selected the 6.3.2 version and we deselected the WebAssembly, the ARM version, and the MinGW compiler version, which we don't need. We are only using the Microsoft Visual Studio 2019 compiler version. This is also why in the setup of Visual Studio, even though nowadays already the 2022 version is the most up-to-date which Microsoft distributes, we still need to select the 2019 toolchain. Qt is currently not offering the newer compiler as a pre-built binary. Of course, it would be an option to compile an own version of Qt, but that's a lot of work and time and not really worth it. I just see we also should deselect Android since we are not going to do anything for Android. Any questions about the software pre-requirements that you might want to ask now? Okay. Apparently not, so let me close this and that. And since no more people are coming, I guess we'll just wait 3 more minutes, not the full 15. That would be the Akademisches Viertel time, but I guess we don't want to waste too much time. If they didn't show up by now, they probably will not show up later. And if they do, they can always rewatch the YouTube video afterwards to hear what they missed. So, well, yeah, 2 more minutes to wait. Any questions? Waiting is always so boring. Well, let's start. So, first of all, you can start Visual Studio if you have it already installed. You will need to have the Qt plugin, or rather Qt extension, installed as well. But since that was already subject on during the exercise, and I have uploaded to the Moodle a short installation guide that shows you how to install all the components. Although it still refers to the older Visual Studio version, the steps are all virtually the same, so I guess this is good enough. And once everything is installed, you start Visual Studio, you get a screen like this, and we can either create a new project. So let's do that again. So it's the wrong button. Create new project. We will again go with a Qt widget application, since it contains most of the elements that we might want to demonstrate. We just call it Qt test. Here we just leave everything at the default. On the second screen we activate precompiled header to make the project build faster. In this case, as a large set of headers which are usually used by every file in the project are just compiled once instead of being compiled every time for every file. This is a very old improvement that's available in pretty much every Visual Studio version I ever used. So we select this as well. And here we have the Visual Studio. One thing that is also quite interesting, if you go on properties for the project, and you get through the Qt plugin here this extra Qt project settings page, on which you can select the configuration of your Qt installation. And for example, one of the most important settings is here this Qt modules, where you can click on select modules, and then you get a whole list of different Qt components. So Qt is provided as a large library of different function blocks, so to say. Some of them are like core components, like Qt core, which you need to do anything. Then if you want to use UI, have an application which has a user interface, a graphical user interface, and not just a command line, you will need Qt GUI and Qt widgets. And then all the other components are pretty much optional, but for example, we could select network. We can select, what else could be interesting? Qt concurrent, this is a helper, a framework that allows you to easily outsource operations into separate threads. Normal multi-threading functionality is part of Qt by default, but this gives you a couple of very neat extra abilities. If you want to print something on paper or when you use a printer, then there is a separate support module for this as well. But I guess who prints things nowadays? That's so outdated. And I think for our use, this is everything we need. If we ever want anything more, we can come back to this view and edit. One additional thing to mention is that here, when you select, you can select which configuration you're editing, and actually we should have selected here the all configuration option, because we want the modules to always be added to all of our configurations. There is no point in having some of the modules just in one configuration. Network. Okay, if this is done properly, it should doesn't show the same ones. You can just copy it, change the order. Now it should show it properly. Yeah, and with the build configuration, it shows different options. So the nice thing about this property editor is that you really can select any configuration for which configuration you want to have. You have the release configuration, which optimizes the build process for a binary that you would release to your customer, so use in normal everyday use. So it is optimized for speed, and it does not contain debug code which might otherwise hinder the execution of the program. So debug code usually makes your program slower, and also it might be implemented such that it will, instead of running over an error and silently continuing, really break execution and raise an exception to bring your attention to some programming mistake which otherwise could have been resumed. And of course the debug build is kind of the opposite. It will add a lot of additional checks to your code, so that if something is wrong, it will be detected earlier. It will make by this means also the code slower, and also the compiler optimization options will be turned off, meaning that the debug informations you have for your project will much more directly be able to represent your source code, in comparison to a release build where sometimes you might not get very detailed information where something went wrong. And with platform here, what you can select is the architecture of the program. Since nowadays pretty much everything is 64-bit, here we have the normal x64 architecture, which we'll be using. We could add here also ARM64, but since we have not installed the required Qt components for this, and since the computer here is just a normal x68 VM which cannot run ARM code, there is no point in doing this. What you could do is, of course, you could have some remote debug target on which, for example, a small Raspberry Pi on which you can run ARM code and then do some remote debugging and remote development on that platform. But as said, for us for now, this is not relevant. In older versions, you would also very often have here by default a configuration for 32-bit Windows. Since it runs on 64-bit Windows just as good as a native 64-bit application, this for many small applications often was a preferred choice. But since nowadays Windows 11 is only available as a 64-bit operating system, and 32-bit operating systems are pretty much useless by now, given their 4 GB of memory limitation, I think it is enough to always create your binaries as normal native 64-bit binaries. So that taken care of, we can take a short look on the structure of such a Qt program. So as with any C++ application, it starts in the main function. In Qt, it is customary to define an object call of type QApplication, which has to exist as long as the application is running. You can pass to it the arguments which you received from the command line when the process was created. This is useful for two things. For once, on the object, you can just get the command line as a nice string list. Where was that? Where was that? That should be somewhere. Maybe I need to. Where was that? One moment, please. I need to check the right sentence. So Qt changed a few things from Qt5 to Qt6, and here we have already the Qt6, since it's the newest one. So I thought it would be best to install it. So let's quickly check what they changed about getting the command line. I don't think they changed much. Yes? Yes, that is this. That was somewhere. So one very useful resource is the all Qt classes documentation which Qt provides. You can find it at the documentation site, the documentation page. You can there find the verbose documentation for every class they provide. Yes, of course. It's not called command line, it's called arguments. And this gives you a QString object, so which represent in principle the content of your command line. String, but already pre-processed. So it normally when you get this command line arguments directly in a C++ application, the first argument is the path to the application that was actually started, which you usually don't care for. So you would normally start at the second argument. So here this is already sanitized, and what it also do is you can specify some additional debug flags or options for Qt how to internally operate, and this then will be also processed. So it is recommended to always create this Q application object and pass to it the arguments. You could in principle create it also, I think, without providing the you could provide an empty string. You could provide like just null, and then it should accept. Okay, it wants a real variable. But as said, this would not be recommended. Normally, you actually are happy to let Qt handle the command line. Then, what we do here later is we create a new class of our own type. So Qtest is a class that we have here in our project, which will contain the main window. And once we have this on any window, you can just call the show method to make the window appear. And last but not least, we need to start the message loop for the Qt application using this exec option. In principle, you can also run an exec on various sort of dialogues, in which case the execution will halt at this point and only continue once you close the dialog. But internally, the message loop inside the dialog will keep running, so the application will stay responsive. If you use show, it is not blocking, so it just shows the window and the whole thing continues execution. So much about that. So let's quickly start it. It needs some time to compile. This SAD-AFX CPP is the precompiled header, so this takes usually longer, but once it was compiled for the first time, unless you choose to recompile the entire project, it will not be compiled again, so it should be much quicker the next time we start it. And here we have our first window. With Qt you have in principle two really nice ways of creating UIs using this different widgets. One is the built-in Qt Designer, which allows you in a very simple way to just create windows by dragging and dropping elements to wherever you want them to have them. Here we have our initial window, and here we have the list of standard elements. The downside of this method is that you can only use the standard elements plus elements for which a special plugin for this designer was created, which might not always be what you want. First we need to define a layout. So in principle you have these four layouts: a vertical layout, a horizontal layout, a grid layout, and a form layout. So the idea is that they define how the elements that you put in can be arranged to each other. So let's say we go with a grid layout. Then here we need to define the layout as well. Technically this makes like one grid in another grid, but this is a nice way of doing it, and it helps you also to see how it operates. So we can now, for example, add a button and another button and something here, and since it is a grid layout, you can really add also things, for example, like in a grid, and you can also make it span multiple columns or rows, so it's extremely flexible. In other scenarios where you really want just to align elements one to the other, to the other, you can use the vertical horizontal layout. So we can here, for example, delete all those things and then create the same UI different. So now we have only a vertical layout. This only allows us to add elements on top of each other. We cannot put like an element on the side, but we can use a different layout. And now in this layout we can okay, that is we can also drop the elements here on the layout you have if you cannot find it with the mouse. So sometimes if it's collapsed to just one row of pixels, it's difficult. But here, as you see, you can create more or less the same thing as what you would do with a grid layout, but using a vertical and a horizontal layout. I would generally nowadays opt to just use grid layouts always. I don't think you save much by trying to use these individual layouts, unless you are doing really something that is very small and where you really expect that you will never ever have to add something in the other axis. Another thing worth mentioning is that if you want to use more complex, more custom widgets than what are available here, you have two methods. But wait a second, let's compile this and start the window, and then I will show you how this graphical tool really generates C code that then is used by Qt to show you the window. So here, did we start it? I think it was still running. Yeah, no, it's oh, you need to press save. That's easy to forget. So normally all the tabs in Visual Studio autosave whenever you press run, but the designer, since it's an external Qt tool, it does not do that. So you need to manually press manually save it before we rebuild it. So here now you see our window contains the elements that we wanted it to, and if we look into our class, there is this UI setup UI call, and the UI is pretty much just a member variable of this type, and this class is automatically generated by the compiler. So this file here is not, we haven't had to make by hand. It was auto-generated from this Qt test UI file, and this representation is then what gets compiled and built into our application. So if you want to use more advanced controls than what you have here, you have first of all the option to just write all this code on your own, or secondly what you also could do is you can use the code like here, And then let's, for example, add just an empty widget. Widget somewhere here. For example, we want a custom control element here, but which we don't have yet. So by default it will be called widget, but let's call it my widget. Then let's not forget to save. And now what we can do is first of all we'll run it again, so that the code will be this code here will be updated. It will still here, once it's loaded, look the same, since the empty widget does not take much space. But what we can do now here is we can go on UI punct if the intelligence works. Just needs time to think, my widget. And this is now the element. And there are two things what we could do. First of all, for this widget we could just add, give it a layout. So set layout. We need of course a layout, so let's say cool in principle. So this is like the full way of doing it, but in principle what we could also do is when defining the layout, just tell it to which widget it will later belong, and you can save one line of code. So it can also be done. And then we just add a widget. And here, well, we have one overloaded function which just takes a widget and would just put it somewhere. But then we have the more interesting ones where you can specify the row, the column, the row span, and the column span. So row and column, I guess it's self-explanatory. A row and column span means how many columns it will span. Normally it spans one column, like none. It's just the one in which it starts, but you can specify 2, 3, 4 if you want to it to span more. But for now, for our use case, now we just go with 0, 0. I think we have another overload one, yeah, here where you don't have this span, so we can just specify row and column, and it will assume that the row and column span is 1, and the first argument must be the widget. So let's go with a new checkbox, for example, Q checkbox. So all the Qt classes start the name with Q. Another nice thing about Qt is that it has a built-in support for translation. So instead of just writing, let's say, my check, so the checkbox takes as a default argument a string where you can specify the text that will display. And you can just specify the text here this way. But what you can also do is you can write tr, and this will invoke a function which is defined on every Q object there is. It's just defined on the Q object basically, and it helps you using an additional Qt tool to translate your application later on. So even if you don't intend to have a translation right now, I would recommend to always use tr for all the strings which are displayed in the UI which should be localized. Of course, you should not do it for any internal variable and not variable names, but internal parameter names for when you create, for example, a JSON file with a configuration or anything. You should, of course, there not localize your configuration files. That would be very bad practice. But anyhow, now, I said this way we add a widget to this. So now we just use a checkbox, which is quite boring, but you might have some own widgets that you created before that are much more complicated, and you want to reuse them. So this would be a way of inserting them. So here is the checkbox. Another method you could use is a bit more direct. You can still go to my widget, then get the layout in which it is in. So a widget will always know to which layout it belongs if it belongs to a layout. And then on this layout you can replace widget. Then you now need to tell the layout again which widget to replace, and with which widget to replace it. So let's again use a checkbox. Maybe we should just use a variable pair. Okay, so we have here our checkbox, which we will want to insert. Might be something arbitrarily more complicated. Zack. And now the effect will be almost the same. There are minor differences in how it will look if it is done just in this simple way. Okay, they didn't like that. it said it's null. Why doesn't this know what layout it belongs to? That thing should know which layout it belongs to. Let's quickly debug that. But it doesn't. Interesting. But it was already created and it is there. Let's see. So widget we have here. Central widget. This thing is horizontal layout. Where it is added to the widget, it should know where it belongs to. Interesting. What we could definitely do alternatively is just use the layout name that we know by inspecting the code. So we can, of course, here give a explicit name to every element we have. So we could write something else here and this will not change. So if you are editing here around, the names will always stay the same unless you change them explicitly. If you add or copy elements, they will be just added with _2, _3, etc, etc, to avoid conflicts. So you will not end up with like the same name. I'm pretty sure this worked in Qt5 just fine, but apparently in Qt6 it does not. And here it worked. The small difference I referred to earlier between using this approach and this approach is that by default a layout will have some margin. So we could make quickly a screenshot. I think the default value for the margin was something different than 0. So if we would create it this way, then we would get a window that looks slightly different. Yeah, so you see here the height here changed and this space here changed as well, because the whole thing here became bigger because of the margin. And what we can do to avoid that is just to set the margin to 0. Set content margins and now it will look exactly the same as the as when we replace the widget. So the layout is there, but it contains only one widget and there are no margins. So you see again, now it looks the same. Technically, of course, the more components you have in your application, the slower the render of the graphical part might be. But nowadays with modern computers this is pretty much negligible, so it's just fine doing it this way. Of course, for the most elegant way you would do it that way. Yeah, but as I mentioned, I'm quite interested why this did not work properly. Let's try again this check. We'll just reuse the variable and see if in this case it will know which. Okay, no, this is not a good test, because what we get from layout is just something of type QLayout, while grid layout is derived from layout. So of course here we don't know which type we will get, hence we need to use a slightly the more generic type that is available. And this thingy still returns null. Interesting. As said in Qt5 that was different. Let's quickly check Q. This documentation is extremely useful because it gives you information about pretty much every setting that you might have. So here we have the QLayout. Well, it has a layout manager because we added it to a layout. Why it returns null is a good question. Wait. No, that I think. No, that's something stupid. It must be the parent widget. Because the layout would be the layout like here with set layout, which we set to be shown inside the widget, not the layout that contains the widget. This way it's correct. We can repair this example here now. Oops. It's always good to read the documentation, since I mean, as you see here, you have like pretty much a huge amount of classes, so it's not really possible to remember every single detail. Just the general structure of how everything works, and then if you need details, you just refer to the documentation. Didn't this work either? Sorry, check is wrong. We wanted this one. Yep, this works. Okay, this works. This worked now as well. The bug was that I forgot that I actually want the layout that's in the parent widget and not in the widget itself. And this brings us already nicely to a more fundamental feature or property of Qt, namely that pretty much everything in Qt is structured in a hierarchical ownership model. So all of these typical Qt classes, at least all of the graphical classes, are derived from a QWidget, and you always have the option to get the containing parent widget. Of course, the top window will not have a parent widget, but then every element inside the window will be a portion of this hierarchical tree, as you can see here. Is pretty much the exact representation of the tree for our very small simple UI. But you can always go up and then mess around within the parent elements, or you can also enumerate the child elements that are inside the UI component. So for example, we have here 2 push buttons. Let's add a few more. Okay, and this is in the horizontal layout. Let's save it. So what we for example can do as well is UI punct. Okay, it's time to think. Hello. The IntelliSense is a bit slow, I have to say. And then you can get I think it was called children. No, that's not quite right. There are like 2 levels of this there are like two levels of this structure. First of all is the QWidget, which contains, where was it here, the ability to access members, but QWidget itself is derived from QObject, which again provides the same method of parent-child relations, but without any relation to graphical user interface functionality. So some of the functions are redundant, like children, for example. This will give you a QObject list, but what we would ideally want would be a list of just child widgets. But it might not. I think QWidget should have that. Was it called find? No. Okay, it's possible, but with some container types you really have explicitly like widget, and then you can give the index. But apparently with just a non-specific widget, you cannot do that. You really need to go the find children route, and you can specify, however, which type of object you want. So we say we want a Q push button, and what this gives us will be a list of Q push button elements which are localized on this layout. But then actually if we do it this way, then we need again to do it on the widget and not on the layout, because the layout is a part of the widget, but the children elements will be normally children of the widget and not the widget's layout. So You will see me often use this auto keyword because I'm too lazy to type out the types. If we put a breakpoint here and run it, we will later also see which type. Wait, what is wrong? I think I need to add the asterisk here because we want a list of pointers. And once it's no, I don't want to do that. That should be working. It's easy to forget an asterisk. Why isn't this working? Layout widget. That should know which widget it belongs to. Add widget, add layout. Okay, they added it directly to the vertical layout, so we should vertical layout, add widget. Okay, this is a small simplification that you can use. Central widget, it will be the central widget. They will all be they will all be children of the central widget thingy. So usually when you generate such UI code yourself, you would always create a widget and then put a layout in it. But in recent Qt versions, what you can do is you can just put widgets to put layouts, like one layout in another layout directly without having to explicitly create a widget for that. So in this case, all the buttons at this level will be just children of the single central widget. But now it worked. It create us a list. Should be a list of buttons. Why didn't this work? Find button. Only found one. Why did it found only one? It should find more of them. So we have grid layout, tree view. Yeah, and we create here the 3 buttons, and the central widget is always the parent. I might need to for name. We don't want a name. This is fine. And the other option is recursively. This is also fine. But this way this should not work. Yeah, this way it doesn't work. Yes. Well, Qt is what will be taught during this course. In the part 1, we only had normal classes and C and C++. We did not... Nope. No, it's not assumed. Ah, shit. Did I miss it? Nope. I should have... And I just found my bug. I used the intelligence and it defaulted to find child, not find children. Of course, we want the list. So, yeah. Using this autocomplete functions and autocode functions and stuff like that is somewhat risky because if you're not checking what it's doing, it might do the wrong thing. So here you see we have a list of 3 buttons. And what we could do now, for example, is... so normally in C and C++ you know this for, and then you write, let's say, int e is equals 0 is smaller size or count. Qt often offers you size and count functions, and both pretty much do the same thing. I don't know why they cannot decide on just using one. You can do this, and then for example you could now in these buttons just access them either with the add command E and then set text, use again tar, And what you probably know from normal C and C++ is like printf and string formatting with this $sign $s or $sign $d or $ri, etc. Placeholders. In Qt, it's slightly different. They, for some reason, didn't want to use variable argument functions. Instead, they just let you make %1 until whatever, however many you might have. And then instead of writing things in the same bracket, since it's not a variable argument function, what you do is you just use this arg argument. In the first arg invocation will be %1, the second one will be %2, and so on. So you can have as many as you want. And the nice thing is that you can change the order. So we could have %2, %1. So for example, if you translate a text and the syntax of the different language to which you are translating would require you to swap these elements, you can easily do it. With normal C++ and normal string formatting, the order of the arguments would always be fixed. So Qt's approach is in this way much more user-friendly. But since here we only have one parameter, we will have a very simple case. And the nice thing is that arg takes pretty much anything that there is. So you see there are like 15 different functions called arg for different versions of string representation, for different numbers, single characters, double, integer, short, uint, int, long, long, etc., etc. And you also have sometimes additional fields, so you could here specify that you want different representations. So for example, that you don't want base 10. So let's go again to the int. Oh, was it double, short, uint, int. So you can specify field width, which is how long it should be. You can specify which base to encode it to. So normally base 10, but you could also use base 16. Or base 1 if you need something to be a binary representation. And then as a last argument you can specify the fill characters, which tells it with what to fill. So let's say we want a width of 2 and here we want a base of 10, is fine, and as a fill character we want to use 0. So why is that complaining? This is an int. Since it's defined for so many things, it sometimes wants you to explicitly specify what type it should use in the end. So that's the one downside of this arg function. Okay, we need a semicolon. So first of all, we can run this and see how this behaves. So here, as you see, the width is now 2, so it always adds a 0. If we would have more buttons, then it would not do that. I think if it would have more than the amount of fields, unless it's a floating point number, it would not truncate it, because this would just display the wrong number, so that would be bad. But if you specify a width of the field and use a double number, then it would just cut off the zeros if there are too many. And a nice thing about Qt is that for all the Qt built-in container types, you don't always need to just write this normal loop as you know from C, but you can also use a for each. This is technically not a C++ keyword. They implement this using a mixture of quite many preprocessor definitions, so we will not be looking into this in too much detail, but generally speaking, the idea is to give you a simulated for each keyword as it is present in other languages, that just iterates through a container and gives you and invokes the body of your code block for every element. So in this case, it's q button buttons. So as you see here, it's already much less typing than having to write this, and internal, then you can just refer directly to this and do something with. Although in this particular case we don't have now an iterator variable, so I guess we'll just call everything button. I could of course add a variable like int I is equals 0, and then here actually we could use this as it is. So of course it depends on your use case how much you save. I would need to increment I as well, or maybe let's pre-increment it. So as said, it depends on your use case, but in many use cases where you use loops, the loop variable is not needed for the operation directly. It's only needed to get a reference to the next and next and next element. So unless we would really want to do that, we could just go without this and save some space on this for each. So this is like a very basic explanation of how this UI thingies work. As I mentioned already earlier, while all the graphical classes are at some point derived always from the QWidget, the QWidget itself is derived from QObject, and QObject is what primarily implements the main Qt functionality. So now what we will do is we will create another project, a non-graphical one, and explore the inner workings of the most nice part of the Qt framework. So we create a new project. We select desktop. We can select Qt. Go for Qt console application. Next, Qt. Well, Qt test we already used. Qt. Let's call it Qt demo. Okay, so as you see, it's by its structure much simpler. There is only the main file and nothing else. Later we will of course take another deeper look into I need to activate that into other aspects of graphical programming, but I thought that it would be a nice introduction to see what sort of nice UIs and how easily you will be able to create them once you get used to Qt. But as said, now we'll take a look into this main part of how Qt internally works. So as I already mentioned, there is this hierarchy of objects which you can introduce. So let's create a couple of own classes. So let's add a new class. Let's say my class 1. We derive it for Q from large O from QObject. Then we will make a second class called my class 2. Add new item. Sorry, that was the wrong button. New. To the new class. As you should know from other C programming lectures or from part 1, it is customary to start class names with a C, but it's not necessary. The name can be anything. And Qt obviously picked to start all their classes with Q, which is actually quite nice, because then you can create a C or just my prefix version of anything that they use for your own use, which would have a slightly changed behavior. And now for Qt, there are a couple of things that one should keep in mind. First of all, Qt has a set of include files which are just called Q, the same way as the class. So normally, of course, in C++, your headers are a .h file, but since this include directive just includes whatever file has this exact name, the extension doesn't matter, and Qt just thought it would be nicer if they would just call their include files just Q something. Although those files then just only include the QObject. So if we go to QObject, we actually have a QObject H. But if we would look into the include directory, there would be such a stub file that just makes it look nicer. And for every Qt class, a very important thing is to add the QObject preprocessor definition, which adds to this class all the different Qt mechanics that we will be taking a look on just in a minute. So let's create some constructor. Cool. Sorry, constructors will have the same name, so since we are lazy, we just copy the name. It is customary to always add the option to specify a parent. By default it should be null, because we want the option but we don't want to force that. We do the same for class 1. Okay, I should have copied one more line. Class 1. Oops. then we initialize the QObject, giving it a parent. I said in principle, if you don't want this, you can skip this, but I said it's good practice to always provide the option to initialize your own class properly. Okay. So at this point it is still somewhat boring, but it will be start getting funny soon. So we include all those two classes here. Then let's create some instance of the class. My class 1 C1, oops, my class 2 C2. Okay, and what we now can do is we can start with the very nice part of Qt. It is called signals and slots. So in normal C++ programming, or in normal C programming as generally, you always are just calling functions on something, and you need to know the object type, and the function parameters and everything needs to be compatible. So connecting two components together which don't know each other is often somewhat difficult. You will need some derived classes that do the connection, or some other program logic, while in Qt, by using the signals and slots mechanism, it is extremely simple. So let's start with that. So let's define a slot. A slot basically at this level is just a function which can be called from outside, and which uses is that not working? Okay, that's the IntelliSense is not yet quite working. Void my slot. Let's give it a QString text. And the nice thing about this signals and slots, we will see in a minute. It's class 1. So let's create this slot. Let's quickly then check whether it will compile. Oops. Compile as expected. It should, despite the fact that it shows an error, because somehow the IntelliSense, right? Okay, it's no, this is fine. This is also fine. What did I forget? Interesting. That should normally work. I mean, if you look into the Qt objects, they often use this slots. But this one probably not so often, because it's the main object. If we go into the other class here, into our why would they change the demo? Okay. That should be working. Oh, I think it's plural. It's slots, not slot. Yeah. Now it should compile just fine. Okay, and what we will also do is we'll create a signal in our class 2. So for the slot, as I said, it's a normal function. We have defined the function body. We can, for example, make it print the text to the debug console. Oops. And in our class 2, we'll define a signal. Oops. One thing that is important is that there need to be at least some degree of compatibility between those two. So, for example, you can link signals which have more arguments to slots with which has less, to just drop the missing arguments. And at this point, we do not need to define any body, or actually should not define any body for the signal. And now let's use that. So we have created our two things. Now we can object connect send, which we want. Sender will be C2, I think, was it, right? Yeah, C2. Signal. For the signal, we need the name of the variable and the argument list, but without the variable names. And then we have the receiver, that's C1 in this case, then slot, which is, that would be my slot. Voila. What is that? I think I'm missing one bracket. Open, close. Should be fine. What is it complaining about? Or was it the other way around? Sender signal, yeah. Ah, sure. You need to use a pointer here. So normally in Qt you would for the most part use pointers and create your classes on the heap, not on the stack. But here, since we are not inside another object for demo purposes, I did this just on the heap and that on the stack, and that then I forgot to add the reference. So this is fine. And now they are connected. So if you would at some point execute C2 what was it, my signal? That's a mistake. It will invoke the slot, although there is a couple of we need to provide it some text. This tr is not available out if you are not inside the scope of a QObject, because it's a function which is defined on QObject, but you can of course invoke it this way as well. And this connect, the same, it is a static function on QObject. So if you are within some QObject derived thing, like here for example, or let's even better say like there, you could directly use connect without needing anything else. So if we go back to the demo, this way this should actually make a direct connection. So we should be able to try this out if this works, and it should work, at least hypothetically. And then okay, it's still complaining about something. Okay, we need to include QDebug. Hush. Then it should work. It's compiling. It's compiled. And we ended up in our function. So to summarize again, we have two objects which have no understanding of each other. They are just, the only thing they have in common is that they are both derived from QObject. And then from anywhere in the code we can connect a signal to a slot and make and add the ability to call the signal on our receiving object. If we take a look into the call stack, we of course are here in our slot, but if we go up, we see that we end up in some machine generated code again. So this file is generated by Qt, by the framework, when you start compiling your project as a custom build step, and it will contain such call proxies for all the slots that have been implemented. There is also some additional dependence on Qt internal code. We can quickly, what was it, source core lib, that would be Qt base. Yeah, I would find it. And again another object, and in total what it generates is, for every class it will generate an own mock file. Basically it's mock stands for meta object code, and it allows you, so you have one which has this all the signal and the right code to invoke the signal, which then here internally invokes a function in QObject, which then is able to relay this call to the interface of your other class. And there in principle are no limitations how many of these signals and slots you can have. So you could have as many as you want, basically. There are practical limitations from the compiler side that at some point you might not be able to have so many members in one object, but that's like in the range of couple thousand. So realistically, you will never run into this limitation. And the nice thing about this mechanism is that you can use quite many nice Qt provided functions. So let's include QTimer. Yeah. And for example, this allows you, using a function, to call something with a delay. So let's say we want a delay of 1 second. Then you can specify a receiver. So more or less the same way we did here. C1 is the receiver and the slot we want to trigger. Okay, but now of course it will not work because we are missing an argument. So let's say my slot 2 and create a new slot. Is this enough? And this trigger point, and here it needs a reference. That was on class 1, so let's create a second slot, my slot 2, which does not take any arguments. And this we will be able to call with a time delay. So let's again make this. Just want to print test in this case. So let's comment this out, we don't need that. And after the delay it invoked the slot, so here you have quite much more Qt code that was in the call stack that was involved into this timer function. One other thing to show is that even after we executed this slot, the application as such will keep running. So they close that. Yeah, so it is still running. It just did test and it's waiting for anything. You can just close it like this. Or what we could do is we could Q application, quit the event loop. I think we need to include that here. And then the application, actually we could make it even, why is that complaining? They mistyped that main. I think we did not include but I think we cannot include Q application because this is not a UI project. So we need to use the Qt core application. In the graphical project here we could use Q. Isn't enabled. Q application. But the way it's defined, the Q application is derived from a Q graphical application, which is derived from Q core application. And if we have a console project only, then we only have the Q core application available. Let's still print test though. So the quit instruction will terminate the event loop, and when this happens we will exit this auto exec call here. So let's do that first. Then we will just see the application running and normally closing. As you see, it terminated and the window is just left there so that you see the last output. And now another interesting thing, you might remember when we connected this way, if I put the breakpoint here and there, if I run it, you will see that first we end up directly in the breakpoint for the slot invocation. Did I not set the breakpoint? I did not set the breakpoint. Okay, let's rerun it again with the right breakpoint, with the right breakpoint set. So you see, we get into this breakpoint, and then after this was executed, we end up here, and then we would start the event loop. This is because this connect mechanism is aware to which thread an object belongs to and tries to optimize such that it needs as little steps as possible to execute the signal slot connection. We can, however, manually specify that we want a different connection type. Qt where is that? Qt Qt connection. This means that all the data we pass here will be captured in the internal list, and this slot will only be executed once the event loop starts. So it is put on basically on a queue and will be only executed once it starts. We will see this here quickly. So now in this case, first we have to start the event loop, and only after it started, the execution here ended up here. And then we also see that much more operations were needed to reach this point. The reason is, if you have multiple threads in your application, then you should not just cross-call from one thread to another without the necessary synchronization. And since synchronization gives you a lot of opportunity to screw something up, Qt designers thought it would be really nice if you could connect signals and slots from different threads to each other and have them communicate in a thread-safe manner. And this is simply done by those objects knowing to which thread they belong. So there is internally a pointer which refers to which thread they are associated with, and if you make this connection, then it will check if both objects belong to the same thread, and if they do, they will make a direct connection, which is very quick and has little overhead. If they don't belong to the same thread, it will create a Qt connection, meaning that the call to the signal will terminate very quickly, and the other thread, once it comes to executing its event loop at some point, will process the message and then execute the right slot that was invoked, that was connected to the signal emitted before. What you also, of course, can do is do this, like, in principle, the slots are like a convenience feature at this level, but you can also invoke those things without the slot. So what was it? How did that work? One moment, please. I need just to find out how this was called. Slot. There was, like, I think Q meta object or something like that was the right keyword to do that directly. Let's try it. Meta object. Yes. So a process is made up of multiple threads, and each thread is a own line of execution. So basically, like, a thread is one instruction, next instruction, next. So it's like a process up. Forgot to say it in English. Let's just stick to it. It's just you are just executing one instruction after the other after the other. It's basically a whole control flow within one invocation in the process, and those threads, they are running kind of in parallel. So on any system you have thousands of threads, despite the fact that physically you have only a few processing cores. And the way this works is that while your thread and its instructions are being executed, the operating system can at any point in time interrupt the thread's execution and then give the CPU core to another thread, and then this thread will resume wherever it stopped and then continue execution. And by the fact that you have a couple gigahertz at your disposal, this thread switching can be extremely quickly, so that it feels like all of the threads are running at the same time. But due to the mechanism that they are stopped more or less randomly, if you want to access on some shared data from two different threads, then you need to use some synchronization paradigms provided either by the operating system or by the architecture of your hardware to ensure synchronization, such that when you have two concurrent accesses to this data, that you will not corrupt the data or read data which are invalid or anything like that. such a synchronization can be done either by hardware instructions which are built into your CPU, or by the operating system. And Windows exposes a plentiful API to doing those things. And what Qt does, it wraps those mechanisms into really nice classes that you can use without having to think about the underlying architecture on which you are. So in Qt you can use QMutex or QReadWriteLock, and internally it is implemented to use the most efficient methods for any given platform. So you might, for example, on Windows and on Linux, you would use completely different APIs to create operating system synchronization objects and to interact with them. But with Qt, you just use QMutex or QReadWriteLock, and Qt internally maps whatever you want to do on the particular platform-specific implementation. Okay, so we can use this invoke method. Then we specify on what we want to invoke it. So let's say that was where's the reference symbol, C2. Then we need to specify the function name. It was signal1, if I remember correctly. I forgot the comma, and then we can, was it Q, I think. Type was Q string, comma, and then we can pass our string. And then we close this and that. Okay. And if we run this, we should also end up within our slot. Oh, sorry, that is a mistake. That should be slot and not signal. That will not work. My slot. That should work. So if you try to create an invalid connection, Qt will print you a error into the log here, but it will not generate an exception. Okay, why did that not work? I forgot something. So it's class 1. Oh, that should be on class 1. That cannot work. Another nice thing is you can use this connect to connect two signals to each other. So if you want one signal of an object that you own to trigger a signal that you want to emit, yeah, now it works. Then you can just connect signal to signal, and this will work as well. So you don't need to make like an own slot which would just wrap a signal. But as I said here, what we managed to do is already to invoke it directly. And in this set of function, you can also specify Qt Qt connection if you want to. Wait, why is that complaining? I think that, no, sorry, I think that you need to specify this first. There's always the problem with if you have like a couple hundreds of different functions that all just take different amounts of arguments. Okay, yeah, you need to specify this as a third argument. So here we specify the connection type and then the arguments. So the Qt connection, as mentioned, will now take the long way. And what you can also specify is you can specify a so-called blocking connection, meaning that the execution here will be halted until the slot on the other side has been invoked and completed. Of course, in this simple example, this would not work. So what we'll do next is we'll create a second thread. So let's do that here by adding a new class for the thread. Let's call it C my thread, and let's derive it from Q thread. So for example, also creation of threads and managing of threads is a highly platform specific operation. So on Windows and on Linux, you create and destroy and interact with threads largely in a completely different way. So here again, it is very nice that Qt abstracts this for us. So we have just a QThread object, and most of the operations that we usually would want to do on any given thread, we can do using this abstract class, instead of having to implement the same thing for every platform over and over and over again. Okay, so thread we initialize the parent properly. And now let's do that. So for the thread, so normally on Windows and Linux and in any low-level language you use, a thread is basically started just by you calling a operating system function that starts the thread and passing to it a list of arguments as well as a function which should be invoked as the entry point for this new thread. In Qt, this is different, since in Qt the thread will also be represented by a dedicated thread object which is available in our application. They just implemented the entry point for the thread as a virtual function on the thread. So it's this run function. So if we go to the QThread and search for run, we will find that there actually already exists a run function. There also is this exec function which we'll use shortly, and then we have also two signals, start and finished. Because the thread can be created in a suspended state if you would. Well, actually, when you create thread, it is created in Qt always in a suspended state, so it's not running. And then you need to explicitly start this thread. And also, you might want to know when the thread has finished execution. So for this, you have the other finished signal. So where we are, we need to make this proper. Then let's add some body for our function. Here, zack, void. And here, basically, just to demonstrate it, qdebug. Or let's maybe do two threads. How do we do that the best? We need to include qdebug. The nice thing about using precompiled headers is that once we include everything in our precompiled header, we don't need to include everything manually. Oops. Shit. And then we want to add, let's say, this object name. So in Qt you can add quite a few additional parameters to every Q object. So the Q objects are not like very lightweight, to be honest, but they are very useful and very powerful. So nowadays this is, I guess, worth it having them. And one thing that you can, for example, specify for every object is a name, which mostly is not very useful. But what you can, of course, do is you can then look up an object by name. And if you are not using it, normally this will only use as much as one pointer of memory. So it's not very wasteful that there are a couple of those things that you can use, but you don't have to use. But in this case, we will use it because we just start two instances of our thread and make both of them just print to the console string. So again, here we go. Here we include our it was CMyThread C. CMyThread H. For now we will block this. Let's call it T1 and T2. Why is it complaining? Oh, I forgot to set here is equals 0 or null, so that we can create it without specifying a parent. Okay, so we have those to start, and then we can set object name. We just call the threads 1 and 2. Then we can start them. T1, it should be T2. Start. Start. And when we run it, we will see that the text will be more or less just intermingled on the console. Once it starts running, it finishes compiling. Yes, and we need to remove the breakpoint. Okay, two things. First of all, that should have been text2, and second of all, run just runs once, so we need to make a loop that will run forever and just print this thing over and over and over again. And actually what you see is that it manages not to intermix those completely. Apparently there is some synchronization when the QDebug object writes the console, but we can try to break this on purpose just by but this is also, this will not be quite as nice because this always makes a line. So if you make a QDebug, it automatically adds a line break at the end, and between this object it also adds automatically a space. This is not great. Hash include we need something that is more prone to break. Let's use printf. Thread, then printf %s. Okay, thread space printf %s, comma, and now we need somehow to get a C string out of our QObject name, which is internally a QString. The QString is quite nice because it offers all of the functionality that you might ever want from a string, and of course, as you know normal C, there is no string as such in C. There are only so-called C strings, which is just an array of characters, and then you need different functions to do operations on them. Of course, if you use C++ with the standard library, you have the std string, which is a really nice string class, which is kind of basic. So the Qt version of string is much more powerful. In Qt, by default, the string class can represent Unicode text, so there is no like string and string white or anything in Qt. It's always just QString, and it internally finds the best representation it can. And what we can do with Qt is very often we can convert their container types to std container types. So while I would not want to use the naked data from a C string, what I can do is I can convert it to a to std string, which is a non-Unicode ANSI string, on which I can then make call the cstring function to get the internal buffer from the std string which holds the char array. And now, since these are two function calls, we have a good chance that when this will run, we will get some intermingled text showing that the threads really run without any synchronization. Okay, wait, that is not as great. I should have added a \n here probably as well. So let's run this. Zack. Okay, nice. So, and here you see that instead of just writing as before thread 1, thread 2, thread 1, thread 2, it sometimes writes thread 1. So first of all, it sometimes writes thread, then the other thread starts writing thread 2, thread 1 again, then thread 1, then it started running thread, then the first thread managed to write 2, then the other thread wrote thread. So like, it really is kind of intermingled, and the order is not defined, it's random. Or rather, when I say it's random, you know, normal computers don't do anything random, but it's like random in the sense of classical mechanics. If we would know the whole state of the CPU, we can reproduce this exactly, but there are so many factors influencing it, like is your CPU clocking up, down, is the core getting faster or slower because of overheating, what other processes are doing, etc., etc., that for any practical applications, it's random. It's unpredictable for you. That is good enough to call it random. And we can fix this using synchronization objects. Now this is a bit of a detour, since I first wanted to finish explaining those, but since some of you already asked, well, one of you, but very good. Asking it is always good, that makes me happy. How to do the synchronization, we can now already try this synchronization. So let's say that in our thread object, we want each of these objects to be able to write nicely. So let's create a, we can say, protected static synchronization object, qmutex, which probably is not included either. So sometimes if you include some of the Qt libraries, it will include for you already a few others, but often, especially in a core application without the graphical part, it will you will really need to include everything hand by hand. Okay, but anyhow, we have our mutex, we call it mutex, it is customary to start member variables with m, although m underscore is one notation. You could also use this notation. I prefer that notation. Actually, there are people who would say that this is the right notation. It's really arbitrary. Just make a name, and if you understand what it is, it's good enough. If you want to be like very standard adhering, you would either use mmutex or mmutex. But to my eye, this looks the prettiest, and that's why I stick to it. It has the exact same meaning, so it really is no point arguing about it. But since this is a static member, we need to give it a place to live. So here, for example, we will say that it's here. As far as I remember, that thing does not require any explicit initialization. And here we can just lock it. Comma lock. And this function, once invoked, it will either just exit and lock the mutex internally, or it will lock up and wait until the mutex is free, and once it's free, then it will do its lock and then the code. So the next obviously thing important is we need to tell it once we are done, so we can unlock. And what you can do with lock is you can specify an argument. Sorry, not with lock. This is again something that is different on different platforms and frameworks. So in some of them you can just say it in lock. In Qt you need to use the other function try_lock. And try_lock takes a timeout value. But I guess if we try_lock fast, if we look deeply enough into the functions, we'll see that internally they will just be using the same. Why is that not having a body? This is just some placeholder. Nope. We can put a breakpoint here. So internally, very likely both functions are using more or less the same logic. That it is just a shortcut. With the try_lock, what you can do is you can specify a timeout. So if the function will not be able to obtain the lock through a given period time, let's say 100 milliseconds, then it will also continue, but it will return a different value. It will return false. And then what we can do is we can, for example, here either abort or let's abort. Realistically, this will not happen, but it could. So just to have it here. But as I said, with the normal operation, we just use this lock. So let's put the breakpoint here. And now when we run it, first of all, we will see where this lock leads us. Where this is internally implemented. Normally it would be like probably a call of try_lock with a special value that indicates that it should wait forever. It did not end. Yeah. So as you see, internally the implementation of lock is just try fast lock, and if this fails it, then that's the lock internal. So as said, the functions internally behave similarly, but if we now run it, you will see that there is no longer output intermixing, because the threads are blocking each other mutually. We could now add as many threads as we wanted, and we would never run into a conflict situation. Now, of course, this code here, okay, this code is fine, but if we would have here some if and modulo 100 is equals 0, then break. Okay, it doesn't know rand. stdio, no, sorry, stdlib. So rand is just a C function that returns your random. Why is it complaining? That should be stdlib page. I included that. Yeah, the IntelliSense shit. The function. Sorry, that's the reason. That needs to be a double equals. So the function just gives you a random number. It's again not a true random number. It's just generated using a simple algorithm. So it's in a way predictable, but for our use case we don't care. And if this is 0, so if we get exactly something that's a multiple of 100, then we will trigger break, and then at this point, at this point, the whole program will lock down instead of just this one execution of thread terminating, because we forgot to release the. Yeah, and it's dead. That was quick. If we would want to do it properly, when we have locked a resource, before we exit the code block which keeps this lock, we need to unlock it. So if we run now, it will also terminate both threads after a certain period of time, but at least both threads will get the chance to do something. So we see here we terminate one thread, then the other one could run until it also decides it will terminate. And since this is a very common and also extremely hard to pinpoint source of bugs, Qt actually provides you a very nice tool not to need, which avoids you from which prevents you from forgetting to unlock a mutex. Cool. Which is called QMutex Locker. As any nice helpful class, it adds overhead, but given the speed of modern CPUs, it is fine. The locker takes as argument a reference to our mutex, and basically what happens here is it is the object created here on the stack. It will automatically lock. You could, in principle, if you want, unlock it and later relock it, but the important feature is that whenever this thing goes out of scope, so whether it being this break or not this break but the other break or the end of the loop body here, it will automatically do the unlock for you. So no matter what you do, you will not forget, almost no matter what you do, you will not forget to unlock the thing. If you would in fact do something, let's quickly get our code back, which I unnecessarily deleted. If you would kill the thread in which we are right now, so this no, terminate, was it terminate, then at this moment the execution of the whole thread starts. Nothing ever should happen in this thread anymore, so it will not be able to unlock the mutex. But this is not something you should reasonably do. Normally you would just break the loop and then wait for run to end, and when run finishes, then the thread will gracefully terminate anyways. So just to be extra correct on that. So if we run this now, we will see that both again will terminate, but both will manage to finish writing the same way as it was when we had this explicit unlock. And another thing that Qt offers you with regard to this locking and unlocking of resources is a QRead-Write lock, which more or less behaves like a mutex, but it differentiates between read accesses and write accesses. So on pretty much any system, if you have multiple threads running and reading the same memory, this is fine because it's a operation which does not change the state. So as many threads as you have can read always the same resource, and it will be fine. You don't need, in that sense, synchronize a read-only access. The problem starts when you have write accesses, because then if the threads are writing out of sync with each other, they are almost guaranteed to destroy your data and just create some garbage. And the idea of the QRead-Write lock, we can include that as well, is that when you are locking, you are specifying what sort of lock you want. So you can either lock for read or you can lock for write. And you of course have this try functions as well, which would time out and tell you that the lock was not acquired. And the idea how this works is that if multiple threads try to acquire a read lock, all of them will be allowed to acquire a read lock, and they will be able to access the same resource, same protected resource in parallel. But as soon as a thread requests a write lock, then of course the read locks which are still pending will be allowed to run as long as they finish, but no new read locks will be allowed, and at some point then the write lock will be locked. And at this point, this is an exclusive lock. Only this one thread is able to obtain a write lock. So if two threads wants a write lock, they will be given it each after each other, not concurrently. And of course, as mentioned, no read locks will be allowed during this time. Then you can do your write operation. You can unlock your read-write lock. You can of course use QRead locker and QWrite locker instead of QMutex locker to have the same functionality of not forgetting to unlock the resource. And this allows you a really nice access, multi-threaded access to the same shared resource. Windows as such, for example, does not implement internally any read-write lock of this sort. It implements various synchronization objects with which you can construct such a thing, obviously, but it does not have a object that would internally differentiate between those two operations. Another thing to mention as well here, since we're already talking about thread synchronization, is that pretty much any invocation of operating system facilities is a computationally expensive operation. So not just that every system call as such is computationally intensive, but using operating system provided synchronization object is especially computationally intensive, because then a lot of things needs to be done in the kernel. And to make the applications work fast, what is done, for example, when you're writing your application, is that you try to use hardware features as much as possible, because a hardware feature, like some atomic instruction, is maybe it's not just one CPU cycle but 2 or 3, but it's just 2 or 3 or 4 CPU cycles, not hundreds or hundreds of hundreds. Okay, that's maybe excessive, but not hundreds or thousands of CPU instructions. And that's why Qt implemented their own mutex and read-write blocker such that first it tries to use a sort of spin lock to obtain access on the object, and only if it cannot obtain the object and needs to wait, only then the system will invoke, or rather the mechanism will invoke the system's internal synchronizations mechanisms. And this is also one thing where Qt provides a nice wrapper. Q atomic. Was it atomic? No. How was it called? I thought it was called atomic. Okay, I need to use the whole name atomic int, for example. It's not a. It's not that neat. So what we can now do is we can try not using a mutex, a full-blown mutex, but actually create a simple spin lock ourselves using a atomic instruction. So this Q atomic is a atomic representation of a integer. Atomic means that you have a complex, you can call a complex function on it, like something that, like for example, test value, if it's equals to something, change it to something else and return. Okay, in this case it's boring, but because you know what you are testing in. You could have, for example, an increment. So you could have a function that increments your integer and returns whatever value it had before. Or, okay, most interesting operation is test whether the value is, change the value to a new value you specified and return whatever value was previously inside the integer. And all these operations, normally when you write it in C or look on those operations in a disassembly, usually use more than one instruction in the CPU. And since the operating system scheduler can preempt the execution at any point in time, even between any arbitrary two instructions, this way you wouldn't have a guarantee that these two instructions will be executed. But using atomic operations, in fact, you have this guarantee that they will be executed and not interrupted in the middle by the operating system. How this is realized in hardware depends on what hardware you are on, and is something that as a just software developer you would like someone else to take care of. So this is why it's really nice to have here this class that implements it for you. That said, the standard template library for C++ also has a std atomic template which would allow you to do the same thing. So you don't need Qt to just do atomic operations without thinking about the underlying hardware architecture. But going back to this underlying hardware architecture, there are two strategies how those things can be implemented. One is that it really is just one complex instruction which just says do this, this, and this, and then finish, and the CPU internal, whatever it does, it guarantees always that each instruction is executed atomic. And the other strategy is you can use memory barriers or other special instructions that tell the CPU that so you have a special instruction that tells the CPU the following instructions must be executed in one go, and then you have another instruction that tells that you are done with this guarded block, and then the execution can be preempted again by the scheduler. So these are two different strategies. Which one is used depends really on the architecture, but for us it doesn't matter. We can just use one of these atomic operations. So here we will also need it to be a static int m, how do we call it? Let's call it lock. We need to give it a place to live, since it's static, and we should initialize it if it allows us. No, it doesn't allow for initialization, but I think it should be pre-initialized with 0. We will see. So we will comment out this and that and this as well. And the way we do it, we have lock, and then we have a couple of different operations. So we want what to do is fetch and exchange, no, test and exchange, test and set, and then you have 3 different types which define the different memory semantics that would be available. Let's just go with the first one. So expected value is 0, and set value, let's say it's 1, and so what this instruction will do is it will test whether the value in memory in our mlock is 0, and if it is 0, it will set it to 1, and it will return either true on success, or if the check failed, it will return false. So if it was 0 and it was successful, then we are happy, we can do our code. But if it wasn't, then we need to do something else, what we will think about later. But now let's do quickly the unlock part. I mean, we could just make a set and there should be an option to just set without testing, but that again, what is the sign? Store. It was called store. Store relaxed 0. We could also just use test and set 1 zeros, because we know that there will be a 1 inside, but since we know that, why waste CPU cycles or resources, or at least electricity, and just reset 0. So here now we have to think, what do we do if it is already 1? So if it is already 1, if it wasn't 0, this means another thread is in process of printing. We need to wait. So let's say q thread m sleep. So there are different sleep functions. There's sleep. Oh, sorry, let's start. There's sleep, there's m sleep, and u sleep. So sleep, they all do the same thing, but sleep takes an argument in seconds, m sleep takes an argument in milliseconds, and u sleep takes an argument in milliseconds. So let's go with why not u sleep 100, and then we should kind of retest whether we can now obtain the lock. So instead of an if, we will make a loop. So while this does not work, we will sleep, and then we will repeat. And since this is a one-liner, we don't need the brackets. If we would want to make it more sophisticated, we could, well, do a few things, but one would be, for example, count, and then after a certain amount say, okay, timeout. So we could easily implement our own timeout logic. Or if we really want this lock, then we just would do this. Not wait, just try again and try again. And of course, this strategy would create a lot of CPU load, because we would be trying all the time. A sleep operation is something where the operating system is invoked again, so it's not cheap, but it's much cheaper than just trying something a million times over in every second. And basically, when we invoke the sleep command for a given time, then we tell the operating system to suspend the current thread for this given period of time, and the operating system takes care to wake the thread up only after this amount of time has passed. So this is not some knob or some internal loop or anything that it would be wasteful, but it's perfectly fine. The thread does not consume any resources while it is in this sleep state. But as said, the fastest spin lock would be one that doesn't sleep. And in fact, such spin locks are used in the operating system kernel internally a lot, because the kernel itself, it cannot ask itself to do something it can ask itself to do something on its own behalf, but only at different levels of abstraction. So like the mechanisms which are used for synchronization need some other way to implement the synchronization, they cannot refer to themselves. So in different levels on different interrupt levels in the kernel, you can use more advanced synchronization objects, or you can only use spin locks, depending on which IRQL level you are operating right now. If you're operating close to the user level or in passive level, then you can use some efficient locking mechanisms, which will use the more low-level functions of the kernel to efficiently make your thread wait for whenever it is time to do something. But in a normal user mode application, you would not want to just have a very fast spin lock, because that would be extremely wasteful. So what you could, for example, do is, as said, you just sleep here. Let's now run it to see. And another thing you could do is you could use some sort of event mechanism to wake the thread up once the other thread is finished, and that gets complicated very quickly. And this is okay. It's always thread 1. I think thread 2 is just very unlucky. This is the next problem of such a self-made spin lock thingy, that it doesn't guarantee that every thread that asked for a lock will actually get it. It's random. So if we have maybe without a wait, then our second thread will be more lucky. Yeah, now it works, but of course it more or less consumes a shitload of CPU. So if we look here on the Leistung, our virtual cores in the virtual machine are quite busy. Well, it's 50% because we gave it 4 cores and it has 2 threads, so 2 of them are running full blast. Qt guarantees you that every one of those of the lock invocations will get a lock, and it uses a lot of internal mechanisms to ensure that it is very efficient. And at the same time, if you are asking for a resource which is not contested, then it will just use. So basically, the way it internally works is, first it checks with a simple atomic operation whether the mutex is not currently locked by anyone, and if it is not, then it will just lock it. If it is locked, then it will create a structure and some additional event that will be triggered once it's unlocked, and etc. So it will get complicated quickly. But from a performance perspective, if you have uncontested resources, using AQ mutex is really great because it works really quickly. If you would use normal critical sections as provided by some Windows frameworks, like the MFC framework, then it would, as far as I know, always lock and ask the operating system to synchronize, so it would not be as efficient. So Qt is quite good in that sense. Okay, so this much about thread synchronization. But what we now can do is we can also now see what other things we can use threads in Qt for. So let's comment all of that out. This as well. So what we will want to do now is to come back to our signal and slots, and we will. No, we don't need this for now. We will need the start. So we have here our 2 objects. Let's connect them. No, let's do the connection. We will do the connecting later. Let's move the threads somewhere to the top. And what we can do is C1 move to thread. Let's say we move it to thread 1. That's thread 1. And now the object basically will live in this thread once this thread is started. So now when we connect C1 and C2, so C by default when you create the object, it is in whatever thread you are right now. So in this particular example, you only need 1 thread anyways. We have our main thread in which we start our execution, and then we create the C1 object which we move to thread 2. Then we connect, and here we don't specify a connection type. We should start the thread though. So let's just move this up. So the thread is already running, and the thread needs to be able to process events. So inside our run function, we just call exec, and so the thread is created, the thread starts processing messages, the object is moved to the thread, and then we connect our signal from our thread to the object in the other thread. This connect will then automatically go to use the queued connection mode. So if we now invoke this here, then we will see that we will end up in the, where was it, class 1, in this handler from thread from here. So let's just run it and see. Zack, call stack. Yeah, and as you see, it's from exec. Then we have a huge amount of Qt internal code, and at some point we end up here, and here we are as said in the other thread. We are not longer in the main thread. And what we now can do here when connecting, as well as when using this invoke, we can use blocked queued connection, and this means that we will only exit this call once here we have finished the slot. So let's go to the slot again. Where was it? It was this slot, I think. We can add here a Oh yes, I need to include that. Okay, I'm sure one of the things I will show you shortly is how to make your own precompiled header. Let's say sleep for, I don't know, 3 seconds. 3 seconds is a long time in computer terms. But I said it will just block, and then we will return. And the nice thing about using a blocking connection is that now you are in principle able to get a return value from the other thread. So now the 3 seconds passed, that was executed, and then if we continue with F5, then we enter here. So what we do for that was, I think, q return. What was the syntax for that? Return arc. So that's how it was called. Q return arc. Let's say it's also a string, string, and I think we need to q string to have a variable where we want the thing to be returned to. Do we need to pass it as argument? I do not remember. Let's quickly check. It's not at all classes. Does it have a search? Okay, that does not show you an example of usage, but I think, yeah, it takes it by value, so that should be fine. It will fill our ret with whatever value we return, but now we of course need to change our slot to qstring to return something. Okay, now we don't have the function, we need to go manually to it, and let's say it will return text plus 1, 2, 3. Okay, we don't need the sleep, so this was only for demonstration. Sorry, that should be like this. Run. Okay, it's still compiling. And now when we get out of this, it will write to our ret value the return parameter. So this way, we can send data between threads without having explicitly to invoke any additional communication mechanism. The only thing that is needed is the thread to have invoked exec and be in a event processing state. For the thread of which functions for a thread which functions we are calling. The thread that is calling into the other thread using this method, it does not yet need to be in any event processing state. So this is quite nice. So for example, you could have your main application which runs in with a message loop and everything, and then you have a thread which is just a thread which just do not have an own message loop, and it can then, if it just has the pointer to the main application, call into it and ask for data or give data to it, and the communication will be synchronized automatically by Qt in a way such that you will not need any additional synchronization objects. So any questions about those things at this point? Is everything clear? Okay, since no one says anything, then I assume everything is clear. So let's take a look again into our UI application and try to use our knowledge about signal and slots to do something more practical. So for example, all those, actually that code was quite useful. So a huge amount of different Qt UI elements provides different signals depending on what is done. So for example, you have a button will have a pushed or toggled, well actually and toggled signal. A checkbox will have a check state change signal, and a edit box will have a text change signal, and a return press signal, and a couple others. So what we can do here in our loop, which goes through all of the buttons, for example, we could connect each of the buttons to a function. So let's okay, then we will be always connecting to the same function, but why not? So we create a signal. Signals point on button, and it doesn't have any other arguments. It just is a on button function. Suck. Okay, so connect. As you see here, we don't need to write the namespace of C object since we already are in a C object thingy. This wait, no, sorry, sender was first, so need sender, but a p button, comma, null signal must be large buttons. Then if we don't remember what signals it has, we can go to push button, abstract button. Which one we want pressed? We just want to press. So we have a pressed, released, clicked, clicked, and toggled signals by default. Toggled is like if you have a checkbox. So a checkbox is also a derivative of a abstract button, and it works like a button. And you because normal buttons you also can configure such that if you press them, they stay pressed. So it was for them the most expedient thing to have a checkbox, also the same sort of object internally. So, but we go for the pressed signal since we have a normal button. So signal pressed. Even without arguments, we need to add an empty list. Then connect it to this slot, and the slot is our on button. And now breakpoint. Sorry, not breakpoint. Semicolon, and here a breakpoint. And now, if we press any of those buttons, we will end up here in. What did I screw up? Let's that is not good. I think I forgot a semicolon. That's a slot, public slots. Now it will work. So it throws quite cryptic errors if you scrub something with the meta object compiler of Qt. So if we push a button, then we end up here. And what we, for example, also can do is we can give the buttons names. Here, let's be more easy. Let's just go without zeros. And within a signal, you can query the meta object system what send or which object send the signal. So we have a Q object asterisk sender. You have this sender function, and the function will return whatever is the sender of the last signal in the chain that was invoked right now, that is invoked right now. So in principle, you could have a function which you call from onButton, which could query sender as well. This works quite nicely, but of course we don't want just a sender, we want to have the button that presses. So actually this is the button, but we want to have something of the type button. So we can use a cast. So either we just cast without checking anything and hope for the best, and then we can make a do something with it. So let's say hash include q message box. I mean the small large typing doesn't matter, but it's nice to have this nice, and we can show some information. This widget title is test, comma, and the button, so and the text will be the button text, so we can put button and just text. So now when we do that and press a button, we'll get a message box with the text from whichever button was pressed. So this is quite powerful because it allows you to connect things with which... Oh, why is that not working? No, it's working. It's just loading debug symbols for something that we haven't used before. Now it's a quick suck. Yeah, and as I said before, this isn't... Well, this is the normal C way of doing things, but you in Qt you have a special macro. Oops, small c, and QObjectCast, where you specify the type, and if it's something different, then it will return null. So this QObjectCast can check the type of your QObject, and then if it's not the type you specified you want, it will just return 0. So you can here, if this is not null, then do it, and if it's null, then don't do anything. Can we trigger that somehow on purpose? Yes, we can. Let's open our UI editor and add something that would probably have a event. Oh, let's actually do something completely crazy. Let's add a text edit. On which side of the widget? Okay, let's do with a line edit. This is just called line edit. So the initial naming is always kind of trivial. The next ones will then get like 3, 2. So there is no _1. The _1 is the one without _1. But as I said, you can change the names to whatever you like later on. But let's make such a connection. So it doesn't have press, but it has a, what was it? I think it has a return pressed. Let's quickly check it. If this is correct. Yeah, it has return pressed, so that should be fine. Did I not put in any typos? No, I didn't. And then we still connect this to button press. And now if we go here and then press enter within the edit box, we'll of course get in the breakpoint, but the button which we queried will actually be null, so it will be safe. Snack. We are in our breakpoint, but here you see it's null, and then we will not execute this code and not try to get text from well, actually QLineEdit also has a text function, but of course it's a different text function, so it would not work since it's a completely different class. But what we actually could do, if we would wanted to, we can first of all we can be creative with our use of if. So you can put an assignment in an if, and then the thing will check whether this thing is not null, and if it is not null, execute the body, and you will have the variable you defined available in your if in the scope of your if code block. So this is quite funny. QLineEdit per edit. So we can make this an else if. Oops. And then here, zack, we read, as said, since this is C++ and not JavaScript, this text and this text, while they are called the same, they are completely different functions. We could never ever cast QLine edit on the QPush button and expect text to keep working. So this is why we are casting it here to the right type, and then we are also do something with the text. But now we will in fact get a message box, but with the text we entered into the text box. So suck. This is extremely useful and extremely powerful. And the most Qt-ish thing about Qt is really the use of signals and slots, because all the other things that you have in Qt that you might know from other languages, like multiple threads, synchronization objects, typecasting, etc., 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 that you know from other languages. It is a common thing, but the signal and slot mechanism, I have not seen that in, I think, any other language, at least not in the way it's here. And by the given that you are even able to invoke slots without needing a signal, this is really a powerful mechanism. So I think this was a good subject for the first lecture, even though we needed also to make a small detour into multi-threading, which is a huge subject on its own. So perhaps we might make another lecture about multi-threading and synchronization in deep, but for now we already know the very basics about multi-threading and what a thread is. Yes. Another thing to know about Qt, which is not so great, is that Qt can only support one GUI thread. So every interaction with the graphical user interface that Windows or any other operating system you would use Qt on renders has to be done from the main GUI thread. On other operating systems like Windows, every thread can be a GUI thread, and you can have different threads. Basically, you can have one thread for every window in your application, which is nice in a way, because they are then independent. If one of them locks up, it will not influence the others. But the downside, of course, is that then you need different inter-thread communication mechanisms to communicate and to synchronize access to resources. In Qt, it's a trade-off, I would say. One which I think they should at some point resolve, but probably one which is not easy to resolve, because Qt often uses global objects for different things. So for example, while we have defined our Q application here just on the stack in our main function, we can in fact access it from anywhere. So for example, here we can access Q application instance. So in instance, and then we can basically instance returns us the exact address on the stack where A lives. And many other things in Qt are such sort of solitons. So I assume that for them it would be too much of a change to make it possible to run multiple graphical threads. But of course, if they ever do it, that would be a very welcome improvement, since it would remove some of the issues if you have very complicated UIs. Because as said, if you have if every window can be an own thread, then if one of the windows locks up shortly, then it will not block the other windows. But on the other hand, of course, when you think about modern UIs, then they are more integrated. So it's not so common to just open many windows. You rather have a window. You may have some window which you open to set some properties, but you are not operating with one program that opens a dozen windows. So I guess this is fine in that sense. And what you of course can do is you can use the signal and slot mechanism to communicate your backend operations to your UI. And if you program your application, you structure your application correctly, then you should not run into a situation where something in your UI thread should lock up. So this issue is manageable. And I think the amount of use cases where it really would be a problem is very limited. Since normally you would be supposed to make a break like after 2 hours, and then have now until 17:30. I as usual forgot to make the break. I sometimes do that. um, Therefore I think we can finish today a bit early. If you have any questions, you can ask them now and stay longer. I'll be available for questions for the next 15 minutes. During the next lecture, we will I will think something that I will be able to give you as a homework during the next lecture. Something very simple, just with this user interface stuff that you have already seen. Maybe like create a window, put 3 buttons on it, connect them with 3 different slots to 3 different functions, and that's it. Something easy enough that you can probably achieve just by refactoring the code from this demo. I will upload the code here, both those examples, to Moodle, so that you can play with them on your own. I would strongly recommend you to have the Visual Studio and Qt up and running for the next lecture. If you have any troubles with that, as I already said, I think at the beginning, you can call me, not call me, write me an email, and I will try to assist you. We can make a custom Zoom session or something like that. That's not a problem. Yeah. Any questions? If you don't ask questions, I assume everything was clear, and then I will be talking even faster the next time. So it's highly advisable to come up with some questions. Okay. Yeah, no questions. That's also okay, I guess. Yeah. I think during the next lecture we will try to make a more advanced application with something that makes, like, let's say, that makes sense, in contrary to just throwing a few control elements at the window and looking what sticks. Perhaps we will also take a look on the QWT library, which provides the nice scientific, or rather just technical control elements. If you're interested, I will just now keep talking about things you don't need to remember for the next 12 minutes, so unless you have a question, just to fill up time and give you at least some additional information. So this is the library QWT. It's available on SourceForge. It has a Wikipedia page. It's also on GitHub, although I'm not sure if the GitHub version is actually the official one. Is it? It seems to be. Nowadays almost everything is on GitHub, so you also see it's not super often updated, but it doesn't have to be. It is compatible with Qt 6 with only minor changes, so that is quite nice. But we can take, I think, a look on the SourceForge site. They had quite a nice documentation, so we can really make quite many nice plots. There should be somewhere a list of all the different widgets which they offer. Class list, abstract buttons, boring, screenshots. Oh, that's good. So we can have different plots, like really sophisticated ones. It also has features to, like, pickers, so that you can touch something in the plot and get the coordinates or get the data for that. A facility to implement different zooming mechanisms. So it's really a powerful library. We can also take another. It can also do such plots. But I'm looking actually for. It's also boring bar charts for the list of the other control elements. I think they kind of started with we want to have controls for scientific applications, but they pretty much here we have ended up with mostly like 90% of the code are plots, nice plots, and even nicer plots, because the rest is kind of simple. So they implement different additional dials and indicators, which Qt natively doesn't have. So, for example, a much more sophisticated slider, a simple slider, like, from Windows, pretty much one that looks like this, Qt already has. So some of them are slightly redundant, I would say, but these ones are, for example, nice. You don't have this in Qt at all, or at least not in the LGPL part of it. Maybe there is something in the more proprietary part that you can buy if you want to spend 500 euros. I think it's per month, Qt. I remember it is ridiculously expensive. If you really need... okay, I think today morning I said it's like 500 euros per month per developer, but it's actually just $300 per month per user with a 1 year payment plan. So you need to buy a year in advance. And it gets like even more expensive. So this is something I already said today in the morning when I showed you how to install Qt and about their licensing. If you read on their website, they will try to tell you everywhere that you definitely most likely need to buy their license and be able to use their proprietary components. But the simple fact is that for the LGPL code, so like 99% of Qt, or at least 90% of Qt, you don't, and then you can still make completely closed source proprietary stuff as much as you want. And for whatever Qt is not available as LGPL, it is available as normal GPL. So then you just need to go open source with your project, and then you still don't need a license. I think what Qt contains, which actually we didn't install and also didn't have, I think even offered in the installer, are this embedded device framework type of thingy. So that like you can install some kind of Linux-ish operating system that will run one Qt application that you create, and only that on some embedded device. And for this they have like even more ridiculous pricings where they charge you per device per license. You need to have all your developers always paid and enrolled in order to be able to even make updates to your product. So it's kind of, I mean, I understand they need to make money because they need to develop a really great framework, but I think that they are too restrictive with what they allow and don't allow companies to do once they entered such a business license agreement. So not being able to even update your product after you stopped paying for developers is not good, especially if you are thinking only about security updates or minor changes. So I think they might be scaring away more customers than what they actually would have the potential to get interested in their project. So for example, I'm not sure if this really is in the license, but I read somewhere that if you go for their proprietary option, you are limited in as far that you could not even later. No, I think later you might be able to go open source, but I think if you started, that is definitely in license. If you started developing open source, you cannot enter into their license with your project and then make the stuff closed source later on, because they kind of don't want people to develop for 3 years, have a ready product, then pay for then throw out 90% of their developers, then just get licenses for 10 for whatever's left, and then release the product. So I mean, it is understandable from a business perspective in a sense, but I just feel that it is being so restrictive, just scaring away too many customers, too many potential customers. Yeah, still no questions? Okay. Yes, so well, there are two things. There will be homework, and there will be a final project that you need to do. And usually the idea is that the homework is like 50% of the grade, and the final project is another 50% of the grade. And to pass the course, you only need 50% of everything. So in theory, if you know that you can C++ very well, you don't need to bother with the homework, just make a final project and then you will pass. But passing is not a grade that is, well, great. It's just the worst of the worst that is not failing. So I guess for anyone it is good to also do the homework. You don't, generally the idea with the homeworks is that if you want a very good grade, that you should have 100%, but the homework will very often contain optional features, and optional doesn't count to the 100%. So like if you have homework, so everything you do as an optional assignment that is up to you whether you do it or not, it gives you bonus points. So then if you do one of the other assignments not 100%, then you still have enough points to still get the amount of points you would have if you would make no extra assignments and only the mandatory ones flawlessly. So it's not super difficult to get a very good grade, since by doing those extra assignments you can compensate for having screwed up something even a couple of times. So this is fine. And what also is done is that you will get the opportunity to do small things during the lecture, which also gives you bonus points that you can use to compensate for some not well done assignment from the homework, or if the final project is not really good or something like that. Any other questions about this? Normally it's something, an application that you will need to write yourself, that you will be told like write an application which has the functionality X and it has at least to have following features, and then you need to write that application. So for example, the last time we had a text editor, so it's not something that is really difficult. You basically just need a menu bar, a status bar, a text edit in the middle, some qopen file dialog, qsave file dialog, and some other things. So it's reasonably, so it's not super complicated. Now it was a bit, it was not like super trivial because there was a couple of extra features that it was supposed to have, but it's not something that would be extraordinarily challenging to do or so. So it's a generic typical application. Probably this time I will think of something else, but as said, it will not be super difficult. And the way this is done is that so 1 month before the end of the lectures, the project will be assigned. During this time, I think there will be no other homework, but I'm not promising that. Maybe there will be something small. So you have after the lecture 3 more lectures in which you can ask back questions whether how to do something if you are not sure, etc. And you have a month to complete that. You should, I think, give in your project ideally on the last lecture. Technically, you can, I think, have up to 2 weeks to put it in up to 2 weeks late, because after 2 weeks I need to justify why I haven't given you a grade yet. So I don't want to have justify anything. That's why you should put in your work before the deadline to the deadline. But I think a month is more than enough time. And as said, if you have a justified reason to delay it, then you can delay it past the deadline to the deadline. Like if you would have a lot of exams, then it is justifiable. Just don't speculate on it. Don't try to make it part of your plan A. For the normal homework assignment, it usually is done such that it's not due on the next lecture, but always on the over next lecture, so that you have one lecture. So basically the idea is this: I give you some homework. You have a week, you can try to do it. If you do it, great, you can put it in, happy. If you are not sure about something, it doesn't work, you can ask me during the next lecture. There are no minus points, no downsides to asking me questions, as many as you have. And once you got the answers, hopefully then during the next week you will be able to finish your assignment successfully, and then it's the time where you should upload it. If you upload it later than that, they will not be necessarily minus points for that, but if we would do something during the next lecture which kind of is already the resolution, then of course the assignment could not be counted. So don't expect to be able to upload it later than 2 weeks after it was assigned. Rather, well, 2 weeks, I'm saying 2 weeks, but like if there is a holiday, then it will become then 3 weeks, for example. It's like always the over next lecture whenever the over next lecture is. But if you don't manage to do it in time, you have a good chance that you probably will be able to submit it 1 week late without any consequences. More than that, as said, is not good. Any other questions? No more questions? Everything clear? Yeah? Today there will be no homework. But basically, if today would be the next week, then the answer would be yes. Because I mean, for now you should play. You just try playing around with Qt. Maybe one more thing to show you. Once you installed Qt on your disk, there is a huge amount of where was that here? No, it was already here. Examples and more examples. Now these examples, they don't open with Visual Studio. They open with Qt Creator. So maybe I can show this to you quickly. Qt Creator. This is their IDE. For Linux and Mac it's fine, but for Windows Visual Studio is just superior. It should open at some point. But the code is the same, and in principle, well, actually there is a trick. Let's do it. You can so one thing here, you just datei. So first of okay, I have too many windows open. I should give more RAM to this VM. Anyhow, you can already somewhere here Beispiele suchen, search for examples and open them from here very quickly in this Qt Creator. Or you can open Visual Studio, then continue without code. Then extensions, Qt, open Qt project, and then you can go to the example folder. What would be very simple, widgets. Dialog, something very basic. Standard dialogues. That sounds simple enough. Pick the profile. Okay, I should enable the display of extensions. Yeah. So you open the profile, and it will create you a Visual Studio project out of this Qt project. It will need some time to think, but once it's done thinking, okay, it needs to think even more. Now it's done thinking. Is it done thinking? I mean, we're already 2 minutes over time, so we are not compelled to stay. But if you want to see it, I mean, at some point it will just, once it's done with its thing, at some point you will be able to just run it. It's doing. Why does it need so much? Okay, yeah, it's thinking hard. It's thinking too hard. Okay, it's doing some virus check. This is of course annoying, but now it's done thinking, and then you just can start it as a normal project, and then it will show you once it's compiled whatever example we have here. But I think this is like super basic. There is not even a UI file, so it really just contains a dialog made by hand with this layout and widget thingy. So this is like the most basic of basic examples. It's a good pick for the first one. Almost done. Yeah. So here you can learn how to do things, and I would suggest you to watch. So let's say your homework assignment is just to play a bit with the examples. So you don't need to hand that in, you just need to play with it. And once, okay, this also needs to load some more symbols. This will get faster later on, so this is only downloading the symbols the first time we are running it, and this is a fresh virtual machine, so it doesn't know any of them, but later on during the lecture we will not run into these issues. Yay, okay, so we have a few things. We can have a color picker. So this for example is a dialog as provided by Windows, and Qt just uses a wrapper for it. So okay, font dialog, file dialog, these are also quite nice. Okay, this will probably load something. It's like open an existing directory sort of dialog. But the strange thing is that Qt is actually not using here, at least in the past it was not using the write dialog from Windows, it is just using the normal file open dialog, which with a few modifications. So okay, once it's loaded all the symbols, okay, it's loading. Yeah, as said, we are already 5 minutes over time, and we will not be saying anything important, so unless you have questions of your own, you can leave. And unless you really want to see how the dialog works, then just It can just be minutes. It cannot take much longer. It should. Okay, it's loading one more, two more. Ay, ay, ay. Yes? Um, there is none. It is when you compile it, it is already an app. So if you look here, it tells you where it put it. So it's not like something where you have multiple steps and then you have a separate step to make an app, but it is just, where was it, here? You can double click on. Okay, it's complaining because it doesn't have the files in the path, but if you would put all of the necessary files, you could just start it. One thing that you should do, of course, for releases, you switch to the release build and then compile it, but it is not different than a normal development environment. You just use a different preset. Yes. Yes, exactly. Okay, any more questions? Okay. You can make an installer for anything. You can just use a third-party installer tool like Nullsoft installer. Although Qt actually provides an own installer creation framework, which I never used. So if you are interested, we can try that out at some point. But in principle, you can use just any installer creation tool to pack all your relevant files together with your executable and distribute them. You could also just zip everything and give someone a zip file. Tell him unpack it, run it, done. So the nice thing about Qt is that by default it does not integrate almost in any way with the operating system. So it by default does not use COM or other more Windows specific facilities, which really makes it an extremely good candidate to make portable applications. Okay, any more questions? Okay, I guess since there are no more questions and we are already 7 minutes over time, then let's finish for today and we will see each other next time. Bye bye.